Section 4.1 Example 2 says scientists studied the weights of two alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? Alligator 1 had an initial weight of 4 pounds with a rate of growth of 1.5 pounds per month. Alligator 2 had an initial weight of 6 pounds with a rate of growth of 1 pound per month. This problem actually gives us our B and our M. The initial weight is where we would start, and that would be our y-intercept, or B. So here we have B equals 4. The change, or rate of growth, of 1.5 pounds per month is going to be our slope. We can write this as 1.5 or 1.5 over 1. However, it is easier to rewrite this without decimals. 1.5 is the same as 3 over 2. This will be much easier to graph. For alligator 2, we had an initial weight, or starting value, of 6, so B, our y-intercept, will be 6, and the rate of growth, or the slope, was 1 pound per month, so we can write that as 1 or 1 over 1. Keep in mind we're talking about the weights of the two alligators over a period of 12 months. So our x-axis is going to be the 12 months, and the weight will be the y-axis. Since we're going to look at the 12 different months, we can count by ones because we have enough space to get to 12. And then when we're talking about the weight, we start at 4 and 6, and we only go up by 1.5 or 1 pound per month. So we can go ahead and count by ones for the weight as well. For the first alligator, we'll start at 4 on our y-axis, and we'll go up 1, 2, 3, and to the right 2. We can continue this pattern to get some extra points on our graph to create a straight line. For alligator 2, we're going to start up at 6 on the y-axis, and using our slope of 1 over 1, we will go up 1 to the right 1, up 1 to the right 1, and we'll continue this until we have enough points to fill in our graph. Notice that we're not going to extend either of these lines in the opposite direction. We only care about the weight that the alligator started at when the study began and for the following 12 months. Now, if your graph doesn't fit the data all the way to 12 months, that's okay. The important information is when these two alligators weigh the same amount. So as long as you can get to a point where these two lines are going to intersect, that's all the information we need. We can see that at the point 4, 10, the two lines intersect. Therefore, after 4 months, the alligators weigh the same, 10 pounds. Now, it's important to understand which one of these numbers represents the months and which one represents the weight, because the question asks, after how many months did the alligators weigh the same amount? It doesn't technically ask what they weighed, it just asks how many months it takes. So it's important to know that 4 is the actual answer to this question. It took 4 months. 10 represents the weight the alligators were at 4 months after the study began. The work for this problem is written out on the next few slides. And now I would like you to try number 3 on page 232. The number of right-handed students in a mathematics class is 9 times the number of left-handed students. The total number of students in the class is 30. How many right-handed students are in the class? How many left-handed students are in the class?